For this project, we're going to be making a memory card matching game. This will be a 2D game, so we're going to create a new Uni project, and for the project name, I'll call it Memory Game, and we'll set 2D as our default behavior and click Create. We want to import in our assets package, and so I will go to my memory game assets package and import those. So what we're going to have is a series of sprites. We have a back to our card. We're just going to use simple symbols here. We're also going to have a start button and our tabletop, which will act as our background. Drag and drop the tabletop here into our scene. And for its position, I'm going to set it to 0 on the X and Y and 5 on the Z. That's for our layering, which comes later. I'm going to save this scene as just scene. So I'm going to do save as scene, put it in my scenes folder. And what we want to do is we want to ensure our main camera is set to orthographic. If we set our 2D project correctly at the beginning, this should already be set. For our size, I'm going to put 3.84 for our aspect. And we'll move the camera's position to -100. Just make sure that there's plenty of room and depth to be working here. Okay. What we're going to do is set our background to pure black. So I'm going to click in my swatch and bring it down here to black. Right. And we'll start working with the crescent symbol here. I'm going to drag and drop it here into the scene. We'll get one card working correctly, and then we'll kind of bring in all the other cards. And what I'm going to do is I'm going to rename this object to memory card. And I'll set its position X to -3 and a +1 on the Y. And so what we'll have is a line of 4 cards here at the top and 4 cards underneath it. Okay, I'm going to take the card back and bring it here into my scene as well. And now that it's in the scene, I'm going to drag and drop card back onto the memory card object to make it a child. And now that my child object has a position here which is relative to its parent, I'm going to zero it out on the X and Y, which should put it directly over that current card that's there. I'm going to change the Z to -1. All right. I'll select the parent card, and I'm going to add a component to this. I'm going to go to my box collider 2D and add that box collider 2D to it. And we'll start making a script to kind of work with button clicks and actually tracking how the memory card works. So I'm going to create a folder called scripts, and then I'm going to create a script that I'm going to call memory card. And this memory card script will be attached to the memory card object. So I'll drag and drop that on there, verify I have it there. And go ahead and double click on memory card to get Visual Studio open. Opened up. We're going to give ourselves some space up here for some variables. I'm going to create a serialized field that allows us to see the private variable inside of Uni. So I'm going to say private game object. I'm going to call this card back. And what we're going to do is we're going to use a built-in Unity method called onMouseDown. And I'm going to make this public. But when I start typing out on mouse, you can see Unity is starting to identify some of the built-in methods. So we want the built-in onMouseDown. It needs to be spelled and cased exactly as shown here. And what we want to know is if the card back is visible, let's say if card back dot active self, we want to make it visible when clicked. Actually, not visible, we want to make it invisible. So that'd be my card back dot set active to false. I'm going to get rid of start and update. And so this will be my starting point here for my card. I'm going to save the script, come back here to Unity. Alright, so back here in Unity, I'm going to select the memory card object. I can see now that serialized field is open here. I'm going to drag and drop the card back into that slot. And what we're going to do is we're going to test this out by pressing play. And what should happen in our game field is once I click on that card back, we should expose the crescent card underneath. Because what we have done is we have turned off this card back object. So that looks good. I'm going to save my scene. I'm going to deselect everything in my hierarchy. I'm going to create an empty game object. And I'm going to rename this Game Manager. And it's always a good idea to have those empties zeroed out, which, because of the way I created it, it is zeroed out. And I'm going to create a script called Scene Controller. And I'm going to attach my Scene Controller to that Game Manager object. And so now that we have a Scene Controller, we can continue working on the memory card. So we're not going to work on this Scene Controller script yet. We're going to go back to the memory card script. We're going to add some stuff to identify that Scene Controller. So I'm going to make another serialized field. And so I'm going to say, oops, private. I'm going to be looking for that Scene Controller script now. I'm going to call it controller. And what we're going to do is we're going to set up an ID system. What will happen is when we start matching our cards, we're going to match numbers. Now our player is going to see symbols, and we're going to associate symbols with numbers here in a little bit. But what we're going to do is we need the identification number. And so I'm going to make a private int, I'm going to call underscore ID for identification. And then we need a method to retrieve that value. So I'm going to make a method to retrieve the value. And so this one will be a public int where it's just regular ID. And whenever this method gets called, what we're going to do is we want to get the value of that underscore ID. So I'm going to say get return underscore ID. Just like that. So what happens is this method just reaches out and finds out what the value of that ID is. I'm going to keep pushing my on mouse down here. And what we want to do is we want a method to pass those sprite IDs and images through the game manager. So we're going to make a method to pass new sprites to the game manager. And so I'm going to make a public method that I'm going to call set card. And when this method gets run, it's going to take two pieces of information. It's going to take the ID number, or that what will become the ID number. And it's also going to have a sprite we're going to associate as image. All right, so this ID isn't the same as these. This is just a localized variable when this method gets called. Same thing with that sprite. And so when this method gets called, I'm going to say the card retrieved is assigned an ID number. All right, so that's going to be my underscore ID becomes whatever ID it was when this method was called. And we're going to say the attached sprite becomes the image. And so I'm going to get the component called sprite renderer. And once it gets that sprite renderer, what we want to do is talk to the actual sprite field, and we're going to assign that the image that was passed in. All right, looking good. I'm going to save that script. We'll come back here to Unity. I'm going to select that memory card parent in my hierarchy. We can see that the controller slot is opened up. So I'm going to drag and drop my game manager into that slot. And so now my card is pointing at the correct object that has the script on it. And so now we can start working on that scene controller. So I'm going to double click scene controller and set this up to work on. Once inside the script, we'll set up our variables here at the top. So what we want is a reference to the card in the scene. So I'm going to make another serialized field where we take our private, I'm going to say memory card, and this will be our original card. And what we want to do is we want to take that original card and make an array. For references to the sprite assets. So I'm going to make another serialized field where we take a private array of sprite and we'll just call this images. Now, right now, it's a single variable, but if I put my box braces after sprite, that means that we're going to make this an array, meaning it can hold many different sprites instead of just one. We won't need update in here, but what we will do is inside of start is we want to create a random number. Between 0 and the total number of images in the array. So I'm going to make a localized variable called ID, and I'm going to assign that a random dot range between 0 and the total number of sprites in this array. Okay, so if there's 4, it would be 0 to 4. If there was 8, it would be 0 to 8. So I'm going to say my images dot length. All right, so if there's 8, we're making a random number between 0 and 8. And so we generate that number, and what we want to do is we want to set the card and the image to the ID number that was generated. And so my original card, I'm going to run my set card, right, which is this method right here. We're going to run that set card. We're going to assign it the ID number and the images from the array at that same number. And save the script. Returning to Unity, I'm going to come back, select my Game Manager object. You can see here's my array of images. What we're going to do is we're going to drag and drop our memory card here into the original card slot. And we'll click this gray arrow to expand out my images. And what we're going to do is we're going to put 4 in for our array size. And so from the project panel, what we're going to do is we're going to drag and drop each of the face cards into those elements. And it doesn't matter which order we put those in, because they will be randomized. So I have my crescent, diamond, heart, and square. And what I'm going to do is I'm going to save this scene again. And we're going to test this out by pressing play. And what we're looking for is as we click on this, we should now start getting random cards. It was originally a crescent, but now we're getting diamond. And every time, well, not every time, but we're getting random times, so when we press play, we should be able to click on it and get random cards. Now you might go on a run of 2 or 3 diamonds that all appear in a row, something like that. But you should start seeing the randomization in there. All right. So we're going to stop play and save the scene. And what we're going to do is we're going to go back to our scene controller script now. And what we're going to do is we're going to generate a grid of how to lay out those cards. And what I'm going to do is I'm going to make some constant public variables. So I'm going to say public const, that's my keyword for constant. I'm going to use a whole number int, and I'm going to say grid rows. We're going to have a total of 2 rows. And then I'm going to make another public const int. And this will be my grid columns, or COLS. So we're going to have 4 columns in there. All right, and then we're going to set up some X and Y offsets, because what we're doing is we're going to set up 4 up here, 4 down here for a total of 8 cards. And we need to know how far apart those are going to be spaced. So I'm going to make another public constant. This one's going to be a float. And I'm going to call this offset X, and assign a value of 2. And it is public, so we can adjust this if we need to. Then another for offset Y, I'm going to set that to a value of 2.5. All right, what I'm going to do is I'm going to show you an algorithm. Now, in various ways, we've already kind of been doing different sort of algorithms, but they're very low level sort of things. What I'm going to do is I'm going to show you one that's used in the game industry quite often. What I'm going to do is I'm going to show you the Knuth shuffle. All right, and that's spelled like that, the Knuth shuffle algorithm. And what this does is this shuffles the elements of an array and swaps index, or indexes plural, of the elements of the array. All right, so I'm going to make this public. I'm going to say int, and what we're going to do is we're going to return an array. I'm going to call this shuffle array, where we have in its parameters another int array called numbers. All right, so we'll have this error here until we return, in this case, an array of whole numbers or integers. So what I'm going to do is I'm going to set an array. I'm going to say new array. And what I'm going to do is I'm going to assign that numbers dot clone. All right. And what we're going to do, and you can see it says it creates a copy of an array. So what we're going to do is we are going to clone as a basically another array. And inside of our for loop, what I'm going to do is I'm going to just set, I don't need two ints, and say int I equals 0, and as long as I is a less than my new array dot length, we're going to run this loop and we're going to increment I each time. It should be int I equals 0 as long as I is less than the array. I don't know why I kept pre-filling ints all over the place. Okay, that should be what our array looks like. So we'll make a whole number that I'm going to call temp, and that will be my new array at that I position. And I'm going to make another variable. I'm going to say int r is equal to a random range, in this case between whatever I values is and my new array dot length. And now I have to assign those new array variables. So my new array at that I position is also the same as my new array at that R position. And my new array at that R position then gets assigned that very first temp variable. And so we'll run that for every card in that array, and once all those numbers have been assigned, what we want to do is we want to finally return that new array. All right. What we're going to do is we're going to go up and we're going to modify start and utilize that shuffle. So I'm going to use the first card position. And all other cards will be based on this position. All right, so I'm going to take a vector 3. I'm going to call start position or start POS. That is my original card dot transform dot position. All right, so I'm talking about is taking wherever this card is right now, and that will be my starting position. And we're going to make an array of ID numbers. And what we're going to do is I'm going to say int box braces, and I'm going to call this numbers. Now I need to actually fill that array with the numbers we want. And we'll use our zero base index, and we need them in pairs to match these cards. So I need a pair of zeros, I need a pair of ones, and a pair of twos, and a pair of threes. And after that last three, I don't need a comma, but I do need a semicolon there at the end. So those are my pairs of numbers. And what we want to do is run the method to shuffle the array positions. So we've plugged in these numbers here, but what we're going to do is we're going to shuffle these around so that maybe it will go 1, 2, 0, 3, 2, so on and so on. All right, so I'm going to say my numbers array. I'm going to run the method shuffle array where I feed in those numbers again. And what we're going to do now is that they're shuffled, we're going to set our positions and then place those numbers in those positions. So I'm going to say for int I equals 0. As long as I is less than, we'll say, our grid columns. We're going to increment I each time. And we're going to embed yet another for loop there because we've accounted for our columns. Now we need to account for our 2 rows. So I'm going to make another for loop. So for int, this time I'm going to use j because i's already been used. And as long as j is less than my grid rows, we'll run it. We increment I each loop. Not I, sorry. I'm going to increment j each loop. All right, so what we're going to do is we need our version of memory card. And every time we run this, we'll reassign card. And I'm going to say if I is absolutely equal to 0 and j is absolutely equal to 0. Then what we're going to do is we're going to say that's our original card. So I'm going to say card is equal to the original card. And that what that means is if the starting position just leave the card alone. All right, so that's only if I is 0 and j is 0. If there are any other numbers, then we want to create new cards. So I'm going to say else card, I'm going to assign it, we're going to instantiate another of the original card, and we're going to instantiate that as a memory card. And then we're going to create a variable that'll say int index. I'm going to assign that whatever the value j is multiplied by my grid columns, and I'm going to add to it whatever the I value is. All right, so that lays out my cards, and I'm going to say int ID. We're going to assign that our numbers array at that index value. And you'll notice that we have this error. So what I'm going to do is these 2 lines that we did to make sure things tested out correctly, I'm just going to delete those out. It'll clear up that error. All right. So right underneath that, I'll then take my card. We're going to run that set card method where we feed in that new ID number and the image at that ID number. Actually, it's going to be images, plural, because we're using that right there. Okay, so what we've done now is we've instantiated other cards. We've used those numbers and matched them up with the images. so that they come in pairs now. Again, 0, 0, 1, 1, so on, so on. All right. Now what we're going to do is after all those for loops have been run, we're going to come down here and we're going to say, actually we want to do it inside the for loop because we want to place them now each individually. So I'm going to say float position X is equal to that offset X, and offset X, that should be our I value. Yes, that's our column. So we're going to multiply that by I, and we're going to add to it that start position dot X. So that will increment our starting position on the X, and then we'll make a float for the Y, and that is going to be our negative offset Y. And the reason is as we go down a column, we're actually going down into the negative Y value. So we're going to make that negative Y, or negative offset Y, and we're going to multiply that by J. And we're going to add to that start position dot Y. Okay. So one last line here, what we want to do now is move the newly created card to the new position using the above variables. Okay, so I'm going to take my card and we're going to take the transform position. We're going to assign that a new vector 3 where we feed in the position X for the X, the position Y for the Y, and we're not going to change the Z, so I'm just going to take my start position dot Z and save the script. All right. So from there, after we've saved it, we can come back here to Unity and we'll press play. There's our cards, and they should now come in pairs. So as I click through them, I should have 2 of each, and they should be randomized. So if I stop play and press play again, I should have a different sort of layout here as I click through them. So everything's been shuffled, and what we need to do now is we need to set our scene controller to start detecting when there's matches, as well as only allow the player to flip 2 cards at any given time. So I'm going to go back to my scene controller, come back up here to where my variables are, and what we're going to do is we're going to hold the flip cards in variables, and we're going to only allow them to come in pairs. So I'm going to make a private memory card that refers to the first revealed, and then another private memory card for my second revealed. And what we want to do is set a bool. I'm going to say public bool. I'm going to call this can reveal. And what this does is it's going to return false if a second card has already been revealed. So what I'm going to do is this is going to be a getter. So I'm going to put curly braces. I'm going to put get with another set of curly braces. And I'm going to return if that second card has been revealed and is set to null. Okay, so if my second card is null, then we're going to get true. Otherwise, we will get false. And so I'm going to make a method. I'm going to say public void. I'm going to say card revealed. And that will take a memory card I'll refer to as card. All right, so we need to kind of work between scripts here a little bit. We're going to save that. We're going to bounce over here to our memory card. And what we're going to do is we need to go into our onMouseDown method here. And what we want to do is, if the card back is visible, and we want to ensure only 2 cards are revealed. So, and ensure only 2 cards are revealed. So to set that only 2 cards are revealed, we want to see if the card back is active and my controller is going to allow us that can reveal. Again, we're back over here and we're taking a look at that bool to see if that second card is there. So if that's the case, we're going to leave that active back on self, and what we're going to do is we want to notify the scene controller that the card was revealed. And so I'm holding that in a variable called controller. I'm going to say card revealed, specifically this card. And so that's when the player clicks on the mouse, and what we want underneath that is another method that allows the scene controller, method allows the scene controller to know to hide the card again. And so I'll call this, I'll make it public, so my scene controller can do it. I'm going to say unreveal. And so if this one right here set the card back to false, we want to set that back to true. So I'm going to say card back dot set active to true. All right, so we'll save that. Now we can bounce back over to the scene controller. Continue working on this. So what I'm going to do up here at the top is I'm going to set a variable for my score. So I'm going to say private. This way, you can expand on your game later if you want to add more cards, that sort of thing. So I'm going to set my score variable to 0, and what we're going to do is under this card revealed that we set the framework up before, I'm going to say if underscore first revealed variable is empty. So if underscore first revealed is absolutely equal to null, then the selected card becomes the underscore first revealed. So underscore first revealed is that card that got fed in when this method is run. Okay, but otherwise, oops. So that'll be my else statement. the selected card becomes the underscore second revealed. So underscore second revealed will become the card. And we want to compare. So I'm going to say comparison of the two. Let's say cards ID numbers. All right. And so we're going to run a coroutine for that. So underneath card revealed, I'm going to make a coroutine to check for matching cards. So I'm going to make a private IEnumerator, and actually all IEnumerators are private, but I'm going to call this check match. And so we'll get an error for check match until we return some kind of value from my IEnumerator, but what I can do now is I can set it to call back here inside of card revealed. So we're going to run start coroutine check match. And so inside of this coroutine, I'm going to say if first revealed dot ID is absolutely the same as the second revealed ID, then that means we've got a match. So I'm going to increase my score. So underscore score plus plus. And for right now, I'll just push to the console at debug.log where I say, score. I'm going to append it to that score variable. Otherwise, it wasn't a match. So that will be my else statement. And what we're going to do is we're going to wait 1 second to show the cards to the player. So I'm going to say yield return new. We're going to wait 4 seconds and then in parentheses put 1. So we're going to wait 1 second. And then we want to run the method to unreveal cards because it wasn't a match. So we're going to take our first card, so underscore first card, and run the unreveal method. Again, that is back over here where we set the back to true. We're going to do that for both cards, so both the first and second card. And then finally, I'm going to say whether it was a match or not. We want to clear out the values of the variables. Because if it was a match, then the player should be able to continue playing the game. If it wasn't a match, they go to unreveal. And we want to free up both of those variables. So I'm going to say first revealed, that will become empty. And second revealed becomes empty. All right, so let's save that script and let's come back here to Unity and we're going to test this. I'm going to press play. I'm going to flip over to cards. It was not a match, and after a second, they went away. Now, if they are a match, I get my score of 1, and it allows me to continue clicking. Those weren't a match, not a match, score of 2, no match, score of 3, and finally score of 4. All right. So we're making pretty good progress. I'm going to stop playing. What I'm going to do is I'm going to come back here. I'm going to create an empty game object. I'm going to call this game text. And normally we would use Canvas for these sort of things, but I'm going to show you a different way of implementing some text. So this empty object game text, what I can do is I can go to add component. If I start typing out text, you can see there's something called a text mesh. So I'm going to add a text mesh component to it. Okay, and what we're going to do is down here under text, I'm going to type in score. All right. So once I have score, and I'm actually going to put a colon after, you can see it looks really kind of bad. It's kind of crummy here. The graphic doesn't look quite optimized. This is a drawback to not using Canvas in the built-in UI system, at least as far as texts are concerned. But what we're going to do is we're going to go ahead and just move this and use this. I'm going to put the x value to -4.75, the y value to 3.65, and the z to -10. And I'm going to set the scale to 0.1. And when I do, you can see it shrinks it way down. And so what we're going to do now is down here inside of our text, what we can do is we can set the font size. I'm going to set the font size to 80. And now you can see it is much cleaner. All right. So what was happening was the font size was really small and we were trying to blow it up large, and we were getting some very jaggedy, horrible looking fonts in there. And we can change that font around just kind of like we would anywhere else. If I click on this, the default that I have is Arial, and since that's the only one that's there, I went ahead and set it to that point anyway. And we can see we have our anchors here. These work kind of like the Canvas system UI, where we can say specifically where we want that anchor in the alignment. I'm just going to leave that in upper left and left. All right, so our scene controller needs to be able to talk to that because our player is not going to be able to see this console. We want to be able to show it up here. So I'm going to come back to my scene controller. I'm going to add, after that score variable, we want a container for the game text object. So I'm going to hold that in a serialized field. I'm going to say private, and that component is a text mesh component. And so I'm going to call that text mesh score label. All right. And what we're going to do is down here in our check match, instead of this debug.log, I'm going to do is I'm going to replace that with my score label .text, and I want that to show, in quotations, score, and then I'm going to add to that my underscore score variable. Okay, so we're going to save the script, come back here, select our game manager, and we can see here in the inspector that serialized field, so I can drag and drop my game text there into that slot. And what we're going to do is press play and take a look at this. So looking for a match. Oops. There's my score of 1, 2, 3, 4. Looking good. Stop play and save the scene. So let's work on this start button next. I'm going to drag and drop that start button there into my hierarchy, and I'm going to move that position on the X to 4.5, 3.25 on the Y, -10 on the Z. So it's up there in that upper right corner. I'm going to add a box collider 2D to that. And so when we look at that, that will be our collision for that button. And I'm going to create a script for that button. I'm going to call this UI button. And I'm going to attach that script to that start button object. And let's open that up. All right. And so what we're going to do is we're going to make some serialized fields here. So I'm going to say serialized field, make a private game object, and that will be my target object. I'll make another serialized field. That will be a string. We say target message. And so we want to be able to tint this button as well. So I'm going to make a public color. And I'm going to call this the highlight color. And when we highlight this, we can go to color, and when we put dot, you can see we have a whole bunch of different colors. We could also feed in our own RGB colors if we want. I'm just going to use cyan there as my color. And so when the mouse rolls over this, what we want to do is tap into the same sort of thing we did here with the memory card, where we had this on mouse, but it's a different method altogether. I'm going to say public void. I'm going to start doing on mouse again, but this time we're going to do enter, and this is when the mouse enters a collider. In this case, it's going to be our 2D collider. So on mouse enter, whenever our mouse cursor hits that collider, what we want to do is we want to get that sprite that's actually in there. So I'm going to say sprite renderer, and we're going to refer to this as sprite. We're going to get the component sprite renderer. Okay, so we're holding that sprite in that variable, and we're going to say if that sprite is not empty, so not equal to null. Then what we want to do is we want to tint it with cyan. So tint with cyan. We're going to say our sprite.color. That is going to be equal to the highlight color. All right, so that's if our sprite or our mouse enters. Now when the mouse exits, we want it to go back to what it was before. So whoa, a bit of autofill in craziness there. So public void on mouse exit now. We're going to again take our sprite renderer, which we'll refer to as sprite. Get the component sprite renderer. And we're going to say same thing. If the sprite is not empty, so if the sprite is not empty, then we want our sprite color to be white. So color.white, which will basically make the sprite go back to its normal color. And what we're going to do in addition is not just highlight that color into that cyan, but we're going to actually make it larger when the player clicks on it. So we're going to use on mouse down for this. So I'm going to say public void on mouse down. So if the player clicks, I'm going to take my transform of that. I'm going to change the local scale. We're going to increase that just a little bit. So we're going to make it a new vector 3 where we feed it in. We'll increase it 10%. So I'll make it the x value 1.1, the y value 1.1. The z really isn't going to matter because of the flat game, but I'm just going to keep it consistent. Let's just get rid of start and update. We don't need those. And finally, what we want to do is if the player clicks down on it, we're going to increase the scale, but if they let up on it, we want something to happen. So we're going to make the public void for on mouse up. Okay, so if the player lets go of it, we want this scale to come back to normal. So we're going to take our transform.local scale and we'll assign that the new vector 3. Actually, we don't need necessarily a new vector 3. We just go and take vector 3 and just put .1. And what that is it's shorthand to set all those values back to 1. X, Y, and Z would all go back to 1. All right, and we want to send a message to the target object. So send a message to the target object. And so what we're going to do is we're going to say if my target object is not empty, then our target object, we're going to dot send a message for my target message. Okay, and that's that string that's up here. So we'll save the script, we'll come back here to Unity, we'll select our start button. You should see that UI button script. If you don't have one on there, you should put it in there now. For our target object, we're going to drag and drop our game manager in there. All right. And the target message that we're going to set is, we'll just call it reset. Again, we made that public color. You can change that color around if you want. But what we now need to do is we need to make sure our target object game manager has something to do if reset is clicked. All right. And so we're going to need a method called reset. So I'm going to go back into my scene controller. We need to be able to reset our scene. So I'm going to say using the engine.scene management up there at the top. And what we're going to do is somewhere inside of our script, just carve out a new area for a method. I'm just going to go to the bottom here. And so this will be called public void reset. And it needs to match exactly how we wrote it right here. Make sure not to put an additional space after that T like I just did, because that won't work. We want that character butted right up against the next line, and we want to make sure that it is the exact same spelling here and casing as well. All right. So what happens when we run that, we're going to run our scene manager. We want to load the scene, and we're going to load the name of the scene, which is scene with a capital S. All right. So I'm going to save that script. We'll come back over here. We'll add our scene to our build settings. So I'm going to go to File, Build Settings. I'm going to remove this sample scene by just selecting it and pressing Delete. And I'm going to drag and drop scene in there at my 0 position. All right, so I'm going to stop play or close that window out, and I'm going to press play to test this out. So I want to make one match here as a test. So there's my score, but if I come over here, I get that highlighting effect. If I click and hold down, it gets 10% larger. And when I let go of it, the game should reset. So I knew on the previous game, these two were crescents. Okay, now only one of them's a crescent there. So make some more matches in here. Again, come back here, click and hold, let go, and now we've got a random game again. Again, we keep getting random games. And have that 1 second delay between making matches, or not making matches rather. And there's our matching game.